Okay, so which number did you say? Somebody said something to me?
14.
14.
15.
12. Okay, so
Page
12.
7. No, just
On page 7.
yeah.
Okay, so number 12, they're starting with a regular old rectangle, and then they take one bite out of the corner, right? So here's my sloppy depiction. Here's our first one. And then the next one has just one little piece missing there. And then the next one has like that, right?
Yeah.
And then we got a little staircase. Okay, and so the question is, what happens next? Anybody have any ideas?
Subtract.
From where though? From the top? Yeah, so I think what they did is they took away the corner, and then they took away corner and top, and then the next one they took away was from down there. So doesn't it seem like the next thing is they're going to take away this one right there?
No, the one below that X in the middle.
Oh, you want to take away the corner again?
Yeah, that would make sense.
Okay, because that's what I said, isn't it? They took away the corner, then the top, then the bottom. So now they're going to take away the corner. How many more do we have to do?
It says make a table of the process.
Yeah, just as make a
Yeah, you
table.
put it in the table.
Oh,
You
this
have
was
to
make a
figure out.
table?
Yeah. No, I didn't know the.
Oh, is that why you're asking a question? Because they asked it in a weird way?
Yeah.
Is the process?
Make a table with a process column to represent each pattern. Write an expression for the number. Oh, we're totally off.
Is it n -1?
Yeah, so this is completely different than I thought. Okay, so our table would look like this.
I just counted.
For the first shape, how many squares are there? 24. So 24 goes all the way over here because this is in, this is process, and then what's the last thing?
Output. What if I put input process?
Then you are smarter than me, because that's what you're supposed to do. So it's input, process, output. So we put in our first one we had 24, the next one we had 23, the next one we had 22, and the next one we have 21. Okay, so what's the, what do we got going on? What? You subtract one each time, obviously they're going down, but the tricky part of these things is that we're not trying to figure out how do I get from 24 to 23 and then from 23 to 22 and then to 21. You're trying to go across.
Is it n?
How do I go from 1 to 24, 2 to 23, 3 to 22, and 4 to 21?
N
What?
-1 and -2?
I just put in the
What do you
Because
mean
that would
n?
be for the first
Oh, like
one.
n minus 1?
Yeah.
But see, n right here is 1. And so if I go 1 minus 1, I
So that
get
means
0,
25
not 20.
minus.
Okay.
Yeah.
Nice! Say that again, please.
25 minus.
25 minus n is what we're looking for, because if you notice, all of these pairs of numbers add up to
25.
25. So if I start with 25 minus 1, I get 24. If I go 25 minus 2, I get 23. 25 minus 3 is 22. And 25 minus 4 is 21.
So it's 25 minus
Okay.
10 then.
So
So
n
the
minus.
pattern is the 25s are all the same, and these numbers right here are the same as these numbers right here, which we're calling n. So our whatever is 25 minus n. Okay?
Alright. 13.
Okay, so these were giving you a little trouble because of the whole table.
Yeah, 13, 14, and 15.
All right, sweet deal. There's a bug in my butt. There's a snake in my boot. Okay, so when I was drawing the things, I was totally like still in geometry land with you guys last week.
Seems like I was last week.
Isn't that weird?
Yeah.
I really had that strong feeling this year coming back, that it seemed like I had just walked past Mr. Helvey's store and said, thanks for another great year, see you like this year.
It was just yesterday.
All right, so we have input, process. Yep.
There's the IP
Output. And these are always 1, 2, 3, 4, whatever. And then what do we get? 2, 4, 6, 8? Okay. What do you start with?
Well, like,
No, it was an easy question. What do you start with?
because it
No.
started on 2,
Oh my
so I did
Oh,
start
so you
on
start
2.
with 2. Yeah.
not
So
4.
these are always, what these stand for is this is the first shape, second shape, third
So like,
shape.
it's right, I just didn't put 1.
So, like she was talking to you guys about yesterday, what can you do to 1 to get 2? Multiply by 2. 1 times 3 equals 2. What can you do to 2 to get the 4? Multiply by 2. 2 times 2 equals 4. What can you do to a 3 to get a 6?
So it's 2.
Whoops. Oh, yeah, I kind of did that the wrong way, huh?
Or N.
Usually we put the letter afterwards. So I'm going to say 2 times 1, 2 times 2, 2 times 3, 2 times 4. So our formula is what? 2 times n or 2. You get it? Starting to get a little bit? Okay, what are our outputs now?
Whatever. 10,
14, 10.
15, 20, 25.
Okay. So let's go back to what Stacy said about the very first problem and see if you remember something from geometry.
What did
Okay.
I say?
We talked about problems like this in geometry, which I tried to tell you that yesterday because you were all freaked out. How much are these going up by each time?
5.
Plus 5, plus 5,
Oh,
plus
I
5. You
I
remember
have a
this?
question.
Yeah.
Yes.
I just, because like I keep starting on 1, and for the input I
Oh.
went 5, 10, 15, 20. Is that completely wrong, or is that just
That's
a
kind of
mistake?
completely wrong, yeah.
Okay.
When I said that, I realized that that's sort of an oxymoron that I just said, but I just was hoping nobody was going to say it is completely wrong, not
Okay.
kind of completely wrong. I was trying to be nice, but yeah, it's completely
Well,
wrong.
I didn't know if I was just like
Yeah, no, I'm with
confused or if it's
you. Okay, so since it's going up by 5 each time, what do we know about the formula? Where does the 5 go? What? Oh, okay, so you're working backwards and saying our 0 would be 5, good. But when I'm writing the formula with the n in there, do you remember what that told us?
We're gonna have to
This was, in geometry, you talked about kind of the slope of the thing, and so our formula is going to be, we know, 5 times n. Okay, so if this was going up by 7s each time, it would be 7n. If it was going up by 12s each time, it would be 12n. Now the problem is 5 times 1 equal to 10? No, so I have to add 5 to it, and then I have to check and make sure, does that work for all of these? So this one was 5 times 1 plus 5. This is 5 times 2 plus 5. This is 5 times 3 plus 5, and this is 5 times 4 plus 5. So this is our little formula or whatever, and this is just a cheat for us to figure out how to get this thing here. Okay?
Why did you put the 5 first?
Instead of the n, because 10 billion years ago when somebody did math, they just decided to do it that way, and then now we're all stuck with it. But if it was n5, then kids would be going, why didn't you put the n first? That doesn't matter. Just be happy.
She'll just never
Is the
know.
glass half full or half empty, Stacy? It's half full. Okay. All right, and then I will leave 15 for you to do on your own. Now we've done a few of those. Anything else?
Wait, yeah. Those ones go up by,
29 and 30.
That one goes up by 4 each time, it looks like, isn't it?
yeah, so do you still go?
So it's going to be
1,
4n.
But the,
Yeah.
for
You're
input,
still going to start, your inputs are going to still be 1, 2,
1,
3,
okay.
4. Yeah, that's always going to be the case. Okay, what now?
29 and 30.
29.
But hold on, can we do 50? Can we have some time to do 20?
Yes, I will give you 2 minutes.
I did, but I don't know if it's-
Okay, so for 15, the start is the same.
I know what they all are, but like explaining what.
1, 2, 3, 4. What's the first one?
3, 7, 11, 15.
Okay, so like I said before, you recognize that these are going up by 4 each time. right? So my formula is going to be starting with 4n. Then it's the question of what do we have to do to adjust that to make it work. So if I go 4 times 1, do I get 3? No, what do I have to do? Minus 1.
Oh.
If I go 4 times 2, do I get 7?
Okay,
Minus
we're done
1.
now.
We're done now?
Think like that.
Well, we're trying to teach you how to think like that. Trying to change your brain.
I'm scared.
I like trying.
All right, for what? For 16, you get, yeah, n minus 1. Okay, 20 what? 29 and 30?
29
Okay, 29 and 30 are tricky because the little game that we just played doesn't work. Because what does it go up by from 1 to 3?
Isn't it
It went up by 2, but then this one went up by 6. And so since these numbers aren't the same, we can't use that. Ah, nice. You're multiplying by 3 each time. So if we rewrote this in that format that you love so much, 1, 2, 3, 4, 5. No, I'm just trying to teach you how to think this way. 1, 3, 9, 27, 81. Then, oh, no, that's totally different. That's not what we want. Because now we are just naming the next numbers, right?
Yeah.
Okay. So we're not, I was going to come up with a formula. Okay, so you figured out that 1 times 3 is 3, 3 times 9 is 3 times 3 is 9, 9 times 3 is 27. So 81 times 3 is 243. How many more do we have to do? 2 more.
729.
So that times 3 is what?
720.
Please excuse the
And that times
interruption.
3 is
If you have not,
2,187.
picture taken. Now is the time to go.
So this
The
one,
sponsors will be here much longer, and want to make sure that everybody will get an opportunity.
With the
So,
formula, just
all
make it
ways,
3.
Like, I know what it is,
no, Kara, this one, they don't want you to come up with a formula. Yeah, that's what I started to do too. And that's a little bit more complicated because it's a multiplication thing, so there's actually exponents in there, and we're not going there right now.
Oh, wait, so we don't have to find
You do
the.
not have to find the formula for these,
Use
you
it as
just
the
have to
one
come to that, we use the pattern to find the next 3 numbers, okay?
Okay, never mind.
All right, and then so number 30, same deal, what are they multiplying by each time?
5.
5, so to get the next 3 numbers, you just multiply by 5, okay? All right, so finish those up if you have not already. Turn them in and no
Wait, what
homework.
was